Thank you, everyone. My name is Dominic Preuss. I look after our storage, database, and capacity products on Google Cloud Platform. I'm very excited today, day 3 of the conference, which has been an incredible conference, to talk about how Google has reinvented databases and how those people coming to Google Cloud Platform can learn from us and take advantage of the things that we've learned. So let's talk about the early days at Google. People often say that Google was late to cloud. And while Google got into the public cloud space in 2014, Google has been running one of the largest private cloud infrastructures for almost 15 years. And so even though we've only been working with our external GCP customers for about 4 years, we have 15 years of learnings and technologies we've developed over time that really have made it possible for us to work with GCP customers and enable things that they haven't been able to do before. So the purpose of this talk is to take you through Google's journey, see if that maps to some of the things that you're seeing as customers and some of the journeys you're going through. And then we'll talk to one of the customers that has gone through this journey on GCP. And then we'll take a little time to do a demo, because all good talks have a demo. For those 15 years, Google was internally building technologies that met our use cases. And we were hitting use cases that were a little bit different than the rest of the world was seeing. So we would develop these technologies, and we wanted to push these technologies out to the outside world. But prior to Google Cloud Platform, the only way for us to do this was via white papers. And so we published lots of white papers. So if you go back to 2002, we published the original Google File System white paper. So this was what we had learned running a distributed storage system that we could push back to the rest of the world. We followed that with Bigtable, and we're going to talk a little bit about the origins of Bigtable in this talk. And then that spawned the NoSQL movement and a lot of the things that have happened in the HBase space and in the Hadoop space. Fast forward a little bit, we published the Spanner and F1 papers in 2012. And then finally, we got into the Google Cloud Platform time. So now we were actually able to take these technologies that we had developed and that we'd offered back to the community as white papers and offer them as actual cloud services, public cloud services. So BigQuery is the same technology that was in the Dremel white paper. Cloud Bigtable is the same technology that was in the Cloud Bigtable white paper. And then Cloud Spanner is the combination of the technology that we talked about in the Spanner and F1 papers. And so really, we've been able to take these 15 years of experience and then leverage those as we've gotten into the public cloud to help customers build new and exciting things. So with that, I'm very excited to bring up Chris Taylor to the stage. Chris is an early Googler. He was one of the original authors of Spanner and is our tech lead for all structured storage products, not only in Google Cloud Platform, but at Google in general. Welcome, Chris. So now I get to embarrass Chris. So I really want to start at the beginning, because one of the things that people often ask us about is why? Why did Google have to build its own technology? So first thing for Chris, so why did Google build its own database technologies instead of using what was available?
Well, so I think the thing Google has always had to deal with in its history is scale. A lot of our applications have been internet-facing and internet search, and they just sort of scale with the size of the internet. And when you look at the Bigtable paper, it's full of URLs and signals, and there was really nothing we could pull off the shelf for internet scale. Let's see.
And one of the things that we learned is that as we were doing Bigtable and as we were going through the use cases, I think one of the things we saw was that it ended up being a really good tool for building other things at Google.
Yeah, you started to see us branching out a little bit into more things. Many of them were facing the internet. They were Google customers, and Google has a lot of customers. And so you find that Bigtable is a good hammer to use on all sorts of problems that you come across. And a good example of this is sort of early in my personal history. When I joined Google, I worked on a team called Google Alerts. And Google Alerts sends you email when the web search results change for a query of your choice. My first project at Google was learning to run Bigtable. And the reason I was learning to run Bigtable was because we had a MySQL backend that was getting a little uncomfortable at the number of users, the number of registered queries that we had. And so I did a port.
Cool. And one of the things you like to say to me is that in the early days, we were responsible for indexing the internet, and that doesn't really fit in MySQL. And so that's a common problem that we had.
That's correct.
Yeah. And for the back, we're having a little trouble with the monitor screen. So if you guys could bring up the monitor screen, that'd be awesome. Thank you. So OK, that's kind of the early days of Bigtable. So kind of stepping forward, it sounds like in the early days, we were basically shipping binaries and containers to teams to run their own Bigtable. And obviously today we run very differently in a much more centralized way. So kind of how did Google make that decision? Why did we move to centralized services? So how does that work?
Right. So again, going back to Google Alerts, when I first started with Bigtable, the Bigtable team was handing me a container, and I was meant to go run it. I was on a 2-person team, and I was on call for a Bigtable cell, which was entertaining. I was sending mail to the Bigtable team every couple of weeks because I needed to learn about the command line flags. I needed to figure out how to do upgrades. And I was behind on my upgrades, let's be honest.
You're never behind on anything, Chris.
So there were a few things that Bigtable saw in moving to services here. There's to that earlier point, saving a lot of unnecessary specialization and toil. And there's a certain agility that Bigtable gets from controlling its own release cycles, being able to do upgrades for its customers. We get to change more things than we would expect. This move to services was a painful thing for us. The first versions didn't work that well. There was a loss of control for the teams. The service didn't necessarily get immediately better. But this is something that we iterated a lot on over time. And over a couple of years, because Bigtable could see the customer experience, we could change things quickly, Bigtable got a ton better. 100x improvements in throughput, huge progress in tail latency, cost reductions, adding features. When I came back to Bigtable in 2009, creating a table was a trivial thing. You could just show up, click, get table. And really not that far off from the experience you get today in public managed databases. So overall, the move to services was a huge success for Google. It's very, very rare for anyone at Google to be running their own database. And really, this experience making Bigtable into a service was such a success that when we looked at an offering like Spanner that we built a little bit later, we designed that from scratch to run as a service.
Yeah, as we're going through, we wanted to show a little bit of historical photos. So the prior photo is actually when the internal Spanner service went to GA. You saw Chris was the tall guy in the back. And then this was actually one of the first outages. So the team is working with the customer, who's the smiling guy in the blue shirt, who's actually debugging the problems with the team. So the pros and cons of centralized services. So we've talked a little bit about Bigtable and some of the things learned. So why build Spanner? And I think the question that I always get is, why did we think Spanner was possible, right? CAP theorem, all these other things. So why did we think that this was something we could do?
So I'd like to say it's that we're visionaries of some kind, but it's not really very true. Instead, we were kind of dragged to the realization that NoSQL and eventual consistency weren't working for all of the Bigtable customers. Google changed a lot over this period. We were getting into things like Gmail, Google+, personalized search, and consistency was starting to really matter to some of those things. At the same time, Google's SQL native ads and payments businesses were growing in size, growing in sophistication. They were using MySQL, and it was frankly struggling to keep up. We were sharding it really heavily, needing to reshard it from time to time. And then also we were seeing this sort of steady drumbeat of serious bugs, even the occasional major outage, which were basically caused by eventual consistency ambushing developers. And so sitting in the Bigtable team, we were seeing applications building consistency, transactions, indexes, and even SQL engines as layers on top of Bigtable. And we came to the realization that the hard problems we were avoiding weren't gone, they were just pushed to customers. And so while Spanner in its end state looks big and ambitious, it didn't sort of spring fully formed out of someone's head. It was the next thing we could do based on what we were seeing built around us. I would also say that Spanner was an inflection point for us in technical infrastructure at Google. It was when we decided our job was to take on as much storage complexity as we could handle. And this was really so that Google's many, many businesses could move faster and do more. The more we took on, the more they could not have to do. And we're really not done with this process either. One of the exciting things about coming to work every day is that I can see the impact that Spanner has on Google's business, and I know there's just more we can do and more that we're working on.
Cool. This is actually one of my favorite photos, so why don't you give the background on this photo?
Sure, so this was early days in Spanner. We had a big nightly test that ran on 40 or 50 machines. We called it sys-test. A sort of randomized, really stressful thing. We ran one copy of it a night at that time. And this was our board of Post-it notes to show how we were doing. So this little arrow points to the week we were on. So that will have been a Wednesday. It was kind of a rolling list thing. So every day I would put up a Post-it. It was an X or a check. If it was an X, you can see little marks in pen for what went wrong that day.
There are a lot of X's on there.
Fortunately, we've exited this phase of our history. Yeah. And we now run significantly more testing every night, and it comes up a lot greener. But it was a fun.
See, Spanner starts the same way everything else does. As we talked about, we've been doing this for about 15 years. We've talked about Bigtable and Spanner. And so, what are the things that we've learned kind of running this centralized service over the last 15 years that we think is, that you found surprising that you kind of keep in the back of your pocket, like when you think about these problems?
Sure. So I think the main thing that I take away is an appreciation for just how hard it is to develop and scale a managed database service. I don't know if you can see my hair. I cut it short when I was getting ready for this presentation. But there's a lot more gray in it now than there is in the picture you can see of me on the board here.
We've documented your hair turning gray through these photos.
Yes. So it's been over a decade since the Bigtable paper, a decade of developing Spanner, but half a decade since the paper. And when you get into the code, you can see that while the 20,000-foot architecture is the same as what we documented there, almost all the code is different. There's a lot more of it. And we've learned a lot about why simpler alternatives to what we do are just catastrophic. And this is really an underrated benefit of using a high-scale service like Spanner or Bigtable. We've found that the only way you can scale a Spanner or Bigtable 10x in customers, bytes, or QPS is to decrease outages per customer, byte, or QPS by 10x. Anything else, and the number of failures you have just grows and crushes you as the service maintainer. And that's the treadmill we're on here in GCP databases. But if you're a customer, you likely are not scaling by 10x. You probably aren't even that big to begin with. But you really feel the 10x availability and reliability that had to go into the service during that time. And that's just kind of math working in your favor. Generalizing from it a little bit, I mentioned this a little earlier, Google's gained a lot of flexibility and agility by pushing complexity into its first-party database services and taking it out of applications. That leaves the service very challenging to build, but if you can do the work and get it right, that amortizes really nicely across all of your users.
Yep. It's been really interesting. Obviously you've seen this evolution, but Google with 500 engineers or 1,000 engineers is very different than with 50,000. And so running services for 50,000 engineers is a very different. It's a very different scale problem.
Yes.
Great. And so now you and I have been working together on kind of this journey into the public cloud. Plenty of bumps along the way. And disagreements and collaboration. But of the things that we've learned, kind of what do you think is, what are these learnings you think apply to what we're now seeing with our GCP customers and the journeys that we're seeing from our GCP customers?
Yeah, what we're, I think, learning is that there's not much to this story that is Google specific. Not every customer is building a search engine. That's only a couple of companies. But every application has a database or storage somewhere. And the fundamentals of what you want out of a database really don't change. You'd rather someone else operate it. You want it fast. You want it reliable. And you don't want to spend your app's complexity budget on limitations of your database platform. We also haven't talked much about security, but the list of requirements for that gets longer every year, and that's in every customer all the time.
Yeah, apparently there's this new thing called GDPR that people are talking about. That's new.
Right. So we put years of work into being good at that stuff, right? These problems are really near and dear, and we work on them every day. And we're excited to bring some of those solutions to Google Cloud. Our best work, and really this harkens back to the why did we build Spanner stuff, is when we can study what our customers are trying to do, what they're building, and see what seems like the right thing to build. That's when we excel. Cloud platform's a new era for us. We've been doing the private cloud thing for a long time. But we're excited to work with all of our customers on a system we think is really the future of public cloud databases.
Awesome. So Chris, thank you so much for the historical context. Let's give him a round of applause.
Thank you.
Great. So that's about what Google has learned. And I think what's most helpful for people is the journey that other GCP customers have gone down. So I'm very excited to bring Daniel Spoonhour, AKA Spoons, CTO of Lightstep, to talk about their journey into the cloud.
Cool. Thanks a lot. Great. I'm excited to be here and talk about a little bit of what Lightstep does, how we built it, and how we use some of the tools that Dominic and Chris were just talking about. Right. That's me. Almost everybody does call me Spoons. I feel like that's the first question everyone asks. I used to be a Googler. Now I'm a Lightstepper. And I guess I like to build developer tools. That's kind of what I've been doing over and over again in a bunch of different places. So I wanted to start with a Google paper also, not one of the papers that these guys mentioned. This is a paper that one of my co-founders wrote almost 10 years ago now. It was called Dapper, and it talked about Google's distributed tracing infrastructure. So Dapper was a monitoring tool that was built at Google to help Google engineers understand how requests would flow through the system that had been built. Because each request would hit potentially thousands of machines, thousands of services, and all that data was then being aggregated and flowed back to the user. And understanding where it was slow could have been in any of those services. And this tool was and continues to be really critical in building applications that are composed from these many different services. Fast forward a couple of years, now it's not just Google that's building these kinds of systems. And a lot of other folks have started breaking their applications from monolithic entities into smaller pieces, be they microservices, serverless, all kinds of things like that. But the point is that once we've broken them up, it's easier to build the pieces independently. It's easier to deploy those pieces independently, and it's easier to scale them independently. And that sounds great, right? Maybe if you've done this, you're going to disagree that everything's great, or maybe if you can guess from the picture that maybe not everything's great. Does anyone know Honest Status Page? It's not a real status page. It's like the status page that you wish your service providers had. Anyway, this is one of my favorite tweets. We replaced our monolith with microservices so that every outage could be like a murder mystery. And the thing is, breaking up the application was great in terms of being able to build it, but being able to understand it, especially understanding it from an end user's perspective, just got a lot harder. What we've done is take a story, which had one sort of actor in a sense, and we've split that role into a whole bunch of pieces. And now if you were to read any one of those roles, it wouldn't make any sense. You really need to see the big picture and the whole story. So how did Dapper work? Well, roughly, for every request, for every search, for every RPC between services, Dapper captured timing data, it captured logs, and the connections between those services. This is a lot of data. And if you're Google handling a bajillion requests a second, it's a lot of data. And so Dapper's approach to this problem was actually pretty simple and effective. It was just throw out 99.9% of the data, or maybe even 99.99% of the data immediately without even looking at it. That might sound a little bit crazy, but even with that tiny sliver of data, there's still a lot you can do. So for example, Google runs analyses of the samples it's taken to understand and answer questions like, on average, what was causing web search to be slow over the last week? Was it query rewriting? Was it image search results? Was it a different type of image of search result? Or maybe it was just good old network latency. These are all important questions, and they're critical to prioritizing engineering work and to improving performance. There's a tension, though, between operating at this kind of scale and the features that you might be able to offer in other contexts. So at Lightstep, we took a pretty different approach, and I want to talk about that from the perspective of one of our customers. So Lyft has deployed Lightstep and uses Lightstep to understand their application. They've built using a microservice architecture, and they use this really cool service mesh technology called Envoy to basically proxy requests between those microservices. And one of the things that you can do with that that's pretty awesome is that meant that we could integrate really quickly between Lyft and Lightstep and get kind of instant visibility into how requests were passing from the app all the way through all of their different microservice systems. So how does Lightstep differ from Dapper? The short answer is that Lightstep looks at all of the data. So for Lyft, that means we analyze more than 100 billion RPCs every day. That's something like tens of millions of microservice requests every second. And we think if you're a Lyft engineer, you're firefighting an outage, you want to understand what's happening, every single one of those requests could potentially be important to you. And so we want to make sure that we have all of that data there available to you to answer those questions. To do this, we had to take a pretty different approach to what was done in Dapper. And we had to put a lot of thought and effort into building a really efficient system for processing all of this data. This is part of our team. We've taken what we've learned from Dapper, what we've learned from using and building other kinds of monitoring tools, and we're trying to take all of that experience and bring it to our mission to help developers understand application performance as they adopt these modern architectures and platforms. I would love to talk about the work that our team is doing in building these high-volume real-time event processing systems, but you'll have to come talk to me later about that. I want to take a minute and talk about the parts of Lightstep that are not super high-volume real-time event processing systems. We still need to deploy services. We still need to store timing data, trace data, a lot of other stuff persistently, a whole bunch of stuff that was critical but not unique to our business and to our product. And as Lightstep got off the ground, we had to make a lot of choices. Where do we build? Where do we buy? Where do we use open source? Where do we reinvent the wheel, or hopefully not? So I want to tell you a little story. We're a monitoring service. Maybe you're wondering what tools we use to monitor our monitoring service. And of course, there's a bunch of them. Lightstep is one of those. So we operate a bunch of different instances of Lightstep. One of those we call Meta. And Meta's job is just to keep watch on the rest of Lightstep. And at the time of this story, Meta, like the other instances, included a Cassandra deployment that was used to store some low-frequency information, some low-frequency time series data. And we kept running into problems with resource use. Some of the instances were ooming. We had some problems with the way that we had deployed it on top of Kubernetes, which maybe you can imagine where this is going a little bit. But roughly, what that all led to is some persistent and reoccurring corruption in the underlying SS tables. And this, in fact, led to one of the worst outages we've ever experienced. Luckily, it wasn't in a customer-facing environment, but it still felt pretty bad to have one of our own instances down for quite a while. And a lot of engineering time went into mitigating the problem. I think days of engineers' time just to get us back where it was working again. And we were not out of the woods by any means, because a lot of these configurations were also being used in our other environments, and they just hadn't hit these problems yet. So we quickly did some evaluation to look at some other options. And we ended up with Spanner. Maybe not surprising in the context of where we are today. But it actually, I think, took us less work to migrate from where we were onto Spanner than it would have taken us to build the expertise and just fix the deployments that we had in production live at the time. I think it's really important to look back at the choices we've made and understand what we could have done better and what we learned. In this case, I think it really reinforced for me that you can't overestimate the engineering hours that'll go into understanding and maintaining a distributed storage system. Again, this is all hindsight. I feel like really obvious, but where we were, we were just making a lot of decisions really fast as a small company. But I think, this is one of the instances that I look back on, and whenever we have a choice to use a hosted service, this is the kind of thing I think about, because with something like Spanner, I don't think about the human operational costs. And I'm confident that we're in control, that we can scale it up as we need, and we can make choices about what other technology we want to use to complement that. So if you kind of look under the hood at Lightstep today, like this is sort of that in a nutshell. Some secret sauce on the top, and then Cloud Kubernetes, Cloud SQL storage, and Spanner. Those are kind of the important parts of what we have. As a monitoring tool, our customers have pretty high expectations for Lightstep's reliability. they depend on us to be there even when their own services are not working so that they can better understand what's happening. So as a service, it's part of our brand to be a reliable go-to kind of place. We depend on other services to help fulfill that promise. And so I think to take Spanner as an example, I feel really good about being in multiple regions now and knowing that even fairly large failures in terms of a snowstorm or something like that are not going to affect the service that we provide to our customers. So to kind of close up, if you're adopting any of this cool technology, be it Kubernetes, microservices, cloud functions, whatever it is, but you're having a little bit of a hard time understanding what's happening, first, you can go talk to some folks that are right down at the end of the hall, the Cloud Native Computing Foundation. They are incubating open tracing. Open tracing is an open source API for getting data out of an application into a platform like Lightstep. They're also incubating Envoy and a bunch of other really cool stuff. And then secondly, of course, I would be more than happy to talk to folks about what we're doing at Lightstep. I'm really excited about the technology we're building and the way that we can really help push forward the way that people are building these kinds of applications. So with that, I wanted to thank everyone for listening. I want to thank Dominic and everyone at Google for having me up here on stage.
Thank you so much. That was awesome. Appreciate it. Great. In these sessions, I always find it's the most helpful for GCP customers is to hear the experience and learnings from other GCP customers. And so I really appreciate Spoons being here to do that. Now, we've talked a little bit about the past, we've talked about the present, so now we're going to talk a little bit about the future. So I'm very excited to bring up Deepti and Steve from the Cloud Spanner team, and they're going to take you through a preview of some new things that are coming in Cloud Spanner.
Thanks, Dominic. Hi, everyone. My name is Deepti Srivastav. I am the product manager for Cloud Spanner. And I was, just to give a quick history, I was also responsible for launching Spanner internally. That photo was from my phone that you saw earlier. So my Noogler project was launching Spanner, so I have some history in it. And I'm joined by Steve Middlecoff, who is a senior engineer in the Spanner team. And he's going to show us a few cool things that we have coming out. So I talked about this in my talk yesterday, but basically, as we heard from Chris and Dominic, we've been building Spanner for a long time, and of course, the history of databases is 30+ years long. So we could have added features like, there was a ton of features that we could have added and exposed to our cloud customers, but we really wanted to be deliberate about what we offer on the cloud platform to our customers based on what they're looking for, right? So we added multi-region, et cetera, last year, and then there's two really highly anticipated features that I get asked about a lot that we're here to show today. This is not a promise of timelines or sort of announcements of the feature launch. It's more about what we've been working on and what we hope to have in the next few months. We also launched, before we get into it, we also launched the import-export functionality for Cloud Spanner, which was the top feature demand last week, and we demoed it also yesterday. But today I want to talk about the things we're working on that we think are super cool. So what Steve has here is our UI console. If you aren't familiar with Spanner, this is the UI that we have, and we start with the instance page on our UI. Cloud Spanner instances are like, in other situations, clusters. So basically, this is our unit of replication topology and instance and isolation. So you can have multiple databases inside a Cloud Spanner instance. So in this case, we're looking at a DML demo database. So yeah, the first functionality we're going to talk about is DML, which is doing inserts, updates, and deletes in SQL. So just to be clear, you have the ability to mutate data, to insert, update, delete through the API, but we didn't have this DML capability in SQL, and now we are working on releasing it soon, so we're excited to talk about that. So in this case, our demo database is a ticket info database, and as you can see, the schema on the side, it has account, event, ticket, and all those kinds of tables, fairly standard relational database. And we also have two indexes on the event table, event by date and event by multi-event ID. So now let's actually query the database. Now this is something you can do today. So you can go to the query console and you can actually type in queries and you can get the results right there. So Steve typed in a query to get information for all the events in the event table. And as you can see, we have no multi-event ID set in this table. So let's look at the explain plan, again, something we have today, where you can look at the SQL explain. And as you can see, it's using the index to be efficient about fetching this data. All right, so now what if we wanted to change the multi-event ID to say Cloud Next for all events that happened as of Tuesday, which is when Cloud Next started? So we have an update query, update where, and voila, we have a DML query that completed. So let's look at the explain plan. And as you can see, in our explain plan now, we have apply mutations. So we're supporting explain in the DML case as well. So let's look at what we actually did. So we're not faking this out. Like the data should have changed. It's a live demo. And it should say multi-event ID for all the events that are as of Tuesday. And as you can see, I wasn't lying. We can actually make DML statements work. Now, the cool thing about this is that you can do this for petabyte scale databases or very, very small databases, and you can do it right in the query console. But of course, when we release it, we're going to have it in our API, in the UI, and also through our JDBC drivers. So just again, to be clear, we do have a JDBC driver right now, which is read-only because we didn't have DML statements. And when we launch, we will have the JDBC driver as well. And we plan to have ORM support as we go along, Spring Boot, Hibernate, et cetera, once we have this functionality. So hopefully I answered number 2 of the most frequently asked feature requests. Now, let's look at another feature that I'm super excited about that we're also planning to launch soon. This is called the query statistics feature. So we're back at our instance page. And as you can see, it's the same demo instance. It has the same ticket information as before, the same schema. Now, if we enter the instance in this case, now we have a new tab, Query Stats. And if you click into the Query Stats tab, you can see that we're basically showing you all the queries that took up the most resources in the last, in this case, minute. So we have multiple buckets in which we aggregate this information, 1 minute, 10 minute, 1 hour, 24 hours. So hopefully it gives you a good view of how things are behaving over that period of time. But we're most interested in the last minute for right now. So this is sorted by the top 10 queries by CPU. But if let's click into the first one. So now we have an info pane panel there that shows us more information about this particular query that's been taking the most CPU in the last 1 minute. So it's been taking 261 CPU seconds. And as you can see in our info panel, there's more information like average latency, rows scanned, rows sent, et cetera. So in this case, you can see that the rows scanned and the rows sent are the same, which means that the query isn't doing any aggregations or filters or joins. And if you look at the query text, which is right there, so you can actually inspect that particular query as well, you can see that it's not doing any of those things. So the intuition is accurate here. One thing to talk about here is that the query is using a parameterized value. So it's using bind parameters, and this is actually a useful thing to do in general, both because it helps you with performance and latency, because the query engine can then have an opportunity to cache this query plan so that you don't have to rebuild the query plan every time you run the query. And if you saw the statistics earlier, the query has actually run about 150,000 times last minute, but it didn't have to rebuild the whole query plan each time, even though the account ID value could be different. So it will obviously help it perform better, but also it helps with collecting these kinds of stats, right? Because the engine understands that this is the same query that you're running over and over and over again. So now let's look at another query that's more interesting. So this query took 34 CPU seconds, and so much less than the previous one, and it ran only 1,000 times. But in this case, the rows scanned and sent are different. And obviously, that means it's doing something more interesting with fetching the data and then returning it to the user. So look, we have the query open right there, so we can take a look. And what it's doing is it's fetching all the venues, the seating capacity for all the venues. And Steve is moving faster than I can talk. But in case you wanted to debug the query as it was running in either development or production, you would want to open it and run it and see what it does, right? So you can click on a button right there in that query stats page that'll open this SQL API, query API, and you can actually inspect the query there. You can run it as dran, and you can see that we have Beijing Stadium Category 1 and Category 2 both have 6,000 seats. And if we look at the query explain plan, because we want to see, well, what is it doing, why is it doing it, you can see that it's applying all these filters and doing a cross apply and hash aggregate join. So the idea here is that as you're both developing your system and as you're looking at your system and its performance, you can inspect right there what the thing is doing. Now, this is a plan for this particular invocation of the query, but it can give you an idea of, let's say it's taking a long time and you want to see, well, is it using the right index or not, or do I need to create an index? All those kinds of things you can see by quick inspection. So these are some of the many features we're working on. If you have feedback for us, I'll be here as well after the talk to take your feedback and answer any questions. But hopefully this was as exciting for you as it's been for us. So thank you so much for listening. Thanks.
Thank you, Deepti and Steve. I'm so excited to get this out. I know developers have been asking for this for many months, and so I look forward to when they can get this in their hands. Now, one of the things that I wanted to do, because we have been talking about all of our databases, is give you a quick recap of all the things that we've been announcing here at Cloud Next over the last 3 days. So first of all, Cloud Firestore. So we announced this a while ago in Firebase, so it's part of the Firebase console. So now Cloud Firestore is available to you with the UI embedded into the Google Cloud Platform Cloud Console. It introduces data store mode. So what this means is customers that are using data store can now use the same API with no changes and take advantages of the new features that are in Cloud Firestore. And so what this means is that now all data store customers will be automatically migrated over the next period of time with no code changes, no interruption of service, so that all those data store customers can take advantage of all the new features that are in Cloud Firestore. So we're very excited about this. Second of all, as we've been migrating all of these large enterprise customers, so we talked about Target earlier, we've previously talked about HSBC and Home Depot. As these enterprise workloads are coming over, there's lots of existing applications that require things like SAP and Oracle. So we've talked a lot about our relationship with SAP and all the things that we're doing to provide an amazing experience for our SAP customers on GCP. And now we can bring those Oracle workloads to GCP via our partners, specifically Accenture and some of the other strategic partners that we'll be announcing the service with. Cloud Bigtable, so one of the biggest asks for Cloud Bigtable was the ability to replicate the data. So this had been previously in beta, and it is now launched to general availability with the new improvements for the SLA on availability that comes along with that. Cloud Spanner, we recently announced import-export, which is now available to everyone. And then throughout the rest of the year, we'll be launching the DML, read-write JDBC drivers, and query statistics that Steve and Deepti just showed us. And to make sure that we talk about all of our products and make sure everyone understands the portfolio and the breadth of products that we offer our customers. So Cloud Memory Store is our in-memory managed Redis offering. So if you have Redis workloads that you'd like to bring to Google Cloud Platform and have us manage for you, we're very excited that this is in beta. This is another hotly requested feature from our developers. Cloud Data Store and Firestore, so that beta goes out. So if you have document database workloads, especially if you're developing web or mobile applications, this is an amazing product that we're very excited to get more tightly integrated into the GCP experience. Cloud Bigtable for our low latency scalable wide column stores. There's a number of talks about Cloud Bigtable, but if you have those H-based workloads or some of the Cassandra workloads that we'll talk about in my database migration talk, that is available for people to provide that workload. Cloud SQL, so managed MySQL and Postgres. So we introduced Postgres a little while ago, and now that's in general availability. Again, incredible demand and people asking for managed Postgres. So now that that's there, we're very excited to see all the applications that people are going to build with that. And then Cloud Spanner, so our scale-out, mission-critical RDBMS that we just talked about, really provides a portfolio of first-party services. Now, there's lots of other amazing solutions that are out there. So we're very excited with our partnerships. And so Redis Labs is running a managed Redis offering on top of the platform. MongoDB with MongoDB Atlas. We have a wonderful Elasticsearch service through our partner at Elastic. And we have per second SQL Server images that you can run on GCE, and then we just talked about our SAP and Oracle offerings. So depending on what you happen to be running on-premise, whatever that might be, or wherever you're running your current workloads, we have a set of offerings either through Google Cloud Platform or through our partners to meet those needs. And with that, thank you very much. I appreciate your time today. Please enjoy the rest of the conference, and feel free to come find us after the session. Thank you very much.